everybody, and welcome back to our lecture series on maneuvering boards. This is the final maneuvering board that we will be going over, and this is a stationary mow board. In my opinion, stationary mow boards are the most fun mow boards to solve for, and they have a lot of different uses. Oftentimes, you'll see stationary mow boards being used when we are sailing in formation with other ships for events such as a photo exercise. We can also use stationary mow boards if we are trying to come alongside another ship. For example, if we are conducting an underway replenishment, the oiler will be driving a certain course, and say we are a couple miles away from the oiler and we want to station ourselves astern of it in order to make an approach alongside them. We can use this stationary mow board in order to figure out what course we have to drive and at what speed we need to drive it in order to find ourselves astern of that oiler. This mow board is relatively straightforward. Sometimes you'll see it with one leg that we drive, one course. Other times you'll see it with multiple legs that we have to drive. So for this first part, we're going to go ahead and do a one leg course mow board. The one thing you have to be careful of when conducting or when doing a stationary mow board is making sure to be very careful reading the word problem that they're giving you for true bearings and relative bearings. So I'll explain what we mean when we go through this word problem. All right, so we are steaming in formation. It's a fine Navy day at sea. We're in formation. The guide is on course 045 true. All right, so notice we're starting with the guide. The guide is on course 05 true, not us, the guide. The guide might be the oiler, it might be an aircraft carrier, it might be a cruiser, but they are driving course 045 degrees true. We're going to go ahead and plot this. They're at 12 knots. So 5-to-1 scale, 12 knots. 045 at 12 falls right here. Now normally if we were plotting our vector, it would be the E to R vector, but this is them. So it's going to be the E to M vector that we draw. This is labeled E, and this point is labeled M. At time 1710, we bear 090 degrees relative from the guide and 9,000 yards. All right, this is where I said we had to pay attention. We bear 090 degrees relative from the guide. We aren't at bearing 090, but we are at bearing 090 degrees relative. So we can figure that out just by adding 90 degrees to 045 degrees. And that gives us a bearing of 135 degrees true. And this was at 9,000 yards. So again, we took that 045 true bearing of the guide ship. We're at 090 degrees relative from it. We just added 090 to 045, and we get a true bearing of 135 degrees at 9,000 yards. We'll go ahead and we'll plot this, and we will label this M1, like we do for true course and true speed mow boards. So we are ordered to take station 180 degrees true from the guide at 8,000 yards. Now 180 degrees relative, the guide told us station 180 degrees true at 8,000 yards. You look on here, 180 degrees true, 8,000 yards. This is our M2 point. We're now going to go ahead and connect M1 to M2. And like we do for a mow board for true course and true speed, we are going to parallel this back to the E to M vector. All right, so one part that we forgot to mention earlier is that When they ordered us to come to 180 degrees true at 8,000 yards, they also told us that they want us to have a stationing speed of 15 knots. So they told us get from here to here, traveling at 15 knots. So what we're going to do, like we said before, we parallel this line back to M. We're traveling in this direction, so we're going to draw our line in this direction. And what we're going to do is draw the line until we get to the 3 ring. Because remember, 3 ring will be 15 knots with speed on the 5-to-1 scale. We draw from M back to the 3 ring. And this is an SRM, speed of relative motion line. We'll go ahead now and we'll complete the vector. As we mentioned, it's an SRM line. So that means this point is labeled R. And we get our true course to drive, which is 280 degrees true. We're traveling at 15 knots. All right, so now we want to figure out how much time is it going to take for us to get from M1 to M2. How much time will it take for us to get on station? The way we figure this out is we use our plotters and we determine the physical distance between M1 and M2. You can use the range rings for this. And it is 6,500 yards. Come back down to our nomogram. Put a mark on 6,500. Remember, for nomograms, if we want to figure out relative motion speed, we'll use the SRM line. Figure out the size of this line. Bring it to the 5-to-1 scale. And we get a speed of relative motion of 24 knots. We'll go ahead and we'll mark 24 knots on the nomogram. Then we'll connect the 2 points. And we get a time of 16 minutes. So to sum it up, if we are called into station from 090 degrees relative to station 180 degrees true from the guide at 8,000 yards, it will take us 16 minutes traveling on a course of 280 degrees true at a speed of 15 knots. And that is how you do a 1-leg stationing mowboard. Up next, we will talk about doing a 2-leg stationing mowboard. All right, so we're now going to go ahead and do a 2-leg stationing mowboard. I'll give you the details of the problem and then we'll go ahead and set it up. If you have paper, I'd recommend taking notes as I go through the problem, just so you have something to reference as we complete this problem. The guide is on course 080 degrees true at a speed of 10 knots. The guide bears from us 000 degrees true at 6,000 yards. We are ordered to take station off the port beam at 6,000 yards. We are also ordered not to close within 3,000 yards of the guide. Our stationing speed is 20 knots. All right, so let's go ahead and set this up. The guide is on course 080 degrees true at 10 knots. This part is easy by now. Guide 080 at 10 knots. Let's go ahead and label E and M. The guide bears from us 0, 0, 0 degrees true at 6,000 yards. All right, so we're standing on the bridge of the ship. We're looking at the guide with our alidade, and we see that they bear 0, 0, 0. So it's not 0, 0, 0 relative, it's 0, 0, 0 degrees true. So an easy way to figure out if you get that type of word problem, they bear from us, you'll notice that on the compass rose, you have the big numbers, and next to it there's a little number, and that gives you the reciprocal bearing. We need to be looking at the reciprocal bearing in this case. So we are at 6,000 yards from the guide, looking at the guide, and they bear 0, 0, 0. So this is us, and this is M1. We are ordered to take station off of the guide's port beam at 6,000 yards. So the port beam is the same thing as 090 to port, or 270 relative. So we can just work our way around 90 degrees, 1, 2, 3, 4, 5, 6, 7, 8, 9. That'd mean stationing on a true bearing of 350 degrees true, and we said 6,000 yards. This is M2. We were given the limitations, though, that we cannot close within 3,000 yards of the guide ship. We can go ahead, just draw a circle around the 3,000 yard range ring just as a visual reference. And now what we're going to do is take our slide rule, and we're going to draw a line tangent from M1 to that 3,000 yard barrier we just marked. That's going to look like this. And if the limitation was 4,000 yards, 2,000 yards, 1,000 yards, it'd be the same thing. Just in this case, it happens to be 3,000 yards. We're now going to do the same thing from M2. Draw a line from M2 tangent to the 3,000 yard barrier. Extend it out. And we're going to mark a point where these lines intersect. And this is the wheel over point, essentially. We're going to drive from M1 to here. When we reach this point, we're going to make our turn and proceed to our final stationing point. Now we just solve the problem like we did the first time around. We'll parallel M1 to the midway point. We said our stationing speed was 20 knots. 20 knots will be the 4 range ring. We can just go ahead, draw the vector from M, bring that out to 20 knots. Because we're doing two legs, we're going to go ahead and label this point R1 so we don't get confused. And we determine that our first course to drive is 358 degrees true. At a speed of 20 knots. For our second course, we'll do the same thing. Parallel the line over to M. We'll extend it out to the 4 range ring. We'll connect E to that point. We can label this R2. And our second course to drive is leg 2, 048 degrees true. And that was at 20 knots. Now we need to figure out how much time will it take to get from M1 to M2. So for this, again, we figure out the true distance between M1 and the midway point using our range rings. We get a distance of 7,000 yards. Let's go ahead and mark 7,000 yards. And now need to figure out the SRM for this line. That's with R1 to M. Bring this to the 5:1 scale. Get an SRM of 22 knots. Plot this on the nomogram. Connect it. And we get a time of 9 minutes. This first leg will take 9 minutes. You do the same thing for here. We're going to use the SRM between M and R2 this time. The 5:1 scale, we get a speed of 14 knots and a distance of 6,500 yards. Connect the 2 points. And this will be 14 minutes. So in order to figure out how long it will take to get to station, from the time we are ordered to maneuver, when we're at 1 to M2, all we have to do is add 9 and 14, and we get that the total time to station will be 23 minutes. And that is how you do a 2-leg stationing maneuvering board. All right, so we're going to do one last stationing mode board, and this one is a little bit more of a critical thinking mode board, although the same concepts will still apply. All right, I'm going to read the problem to you. Like I said earlier, I recommend if you're following along, you take notes. All right, so we are in formation. The guide bears 040 degrees true from us at a range of 6,000 yards. The guide is on course 225 degrees true, traveling at a speed of 15 knots. We are ordered to take station with the guide bearing 130 degrees true from us at a range of 6,000 yards. All right, so let's go ahead and set this up. The guide is on course 225 degrees true, traveling at 15 knots. 15 knots will be on the 3 range ring. And let's label these points E and M. The guide bears 040 degrees true from us at a range of 6,000 yards. We'll use these small numbers within the compass rose to find our reciprocal bearings. See that 220, reciprocal is 040. So if we're on 220, looking at the guide, they bear 040. This is where we need to plot our M1 point. And that was at a range of 6,000 yards. M1 would be right here. So we need to take station with a guide bearing 130 degrees true from us at a range of 6,000 yards. Again, we can use these reciprocal bearings. 130 is going to be on the 310 heading. 6,000 yards is right here. We'll go ahead and plot this as M2. All right. The question is broken into 3 parts, so there's going to be 3 separate answers for this one. I'll read the questions first, and then we'll go ahead and solve for each one. First part is, what is our speed if we steer course 320 degrees true? The next one, what is our speed if we steer course 250 degrees true? And what is our course if we use a speed of 15 knots? All right, so we're going to solve for each one of these. And like I said, this is a little bit critical thinking in this stationary mode board. All right, so what is our speed if we steer a course of 320 degrees true? So we know that our heading, we can find that with a vector, right? We're going to connect the vector, the SRM, between M1 and M2, the line that this forms. We want to figure out our heading, which is 320. We can just look along here for 320 and plot a point. Let's see that. 320 is right here. So if we were to steer 320, we would have to travel at a speed of 20 knots, right? This falls exactly on the 4 range ring. We'd have to travel a speed of exactly 20 knots in order to make the station. That part is easy. Let's do that again now. What is our speed if we steer a course of 250 degrees true? All right, let's take this DRM line between M1 and M2, bring it back to M, and look for 250 degrees true. That is right here. Let's connect E to that point. Just label that R2. This one doesn't fall on an even range ring, so we'll use our plotters. Bring this to the 5:1 scale. We get a speed of 12 knots. All right, now the last part of the question, what is the course we have to drive if we use a speed of 15 knots? Well, this is just like a regular stationary mode board where they give us the speed we need to station at. So we take our DRM line from M1 to M2, bring it back to M, and we just follow it along until we end on the 3 range ring. This 3 will give us 15 knots. And we determine we'd have to steer a course of 310 degrees true. And this is how you conduct stationary mode boards. The final lesson that we will do is just a fun mode board that's similar to this one, where it's not your standard problem, but involves some critical thinking. It has a couple of different parts to it as well. Good luck and be safe out there. Safe sailing. We hope you learned something.